This is the brief on the net vertical restoring force in membrane wave derivations. So when you're getting into the 2D wave equation, there's this one critical distinction you've got to grasp. It's all about the difference between the tension force pulling along the surface and the net force that actually makes it move. Let's jump right into the three takeaways. First, the net vertical restoring force is totally different from the tension pulling on some little contour element. See, that tension force is stuck in the tangent plane, pulling sideways. But the net vertical force, that's the one acting on the whole little patch of area, pushing it up or down. Second, why is this net force strictly vertical? Well, the whole point of the wave equation is to look at that up and down motion. So when you add up all the tension forces pulling on a tiny element's four edges, something pretty cool happens. All the horizontal parts just cancel each other out, under the small angle approximation. You're left with just the net force pointing purely in that vertical direction. And finally, physical demos really nail this down. You can see how the local tension forces are always tangent, running right along the surface. But the net force, the one that causes the acceleration, is always, and I mean always, purely vertical. And its strength perfectly tracks the local curvature. The complex physics of a vibrating membrane really just hinges on separating local tangent tension from the net vertical restoring force that drives the motion.